All right, everybody, this is the Diploma prep material. We're on the chapter on logs and exponents, and what I want to do here is solve this log equation. Now, a colleague of mine once told me that what I should really be doing with this when I teach it is showing them to bring all the logs to one side and then eliminate the logs, and he was right here. What I need to do with this first is bring that log over to the left-hand side to make this the log base 2 of x plus 7, okay, plus the log base 2 of x plus 5 equals 3. So now I've got the logs on one side here. Now again, if you are tempted to distribute that, you got to kind of get this rule in your head here that the number of logarithms should be getting smaller, not larger. If you end up with more logarithms than the first equation, you're doing it wrong. Now addition, okay, becomes multiplication. And so in that step right there, I've immediately got it down, again, down a number of logarithms from 2 to 1. Once I'm here, I'm going to get rid of this logarithm by converting this to the exponential form. Sorry, not 2 to the 8th. It's going to be 2 cubed, which will equal 8, but 2 cubed will equal x plus 7, x plus 5. Now I've got no more logarithms. Now this is just going to end up being a quadratic that I can solve. So 2 cubed is 8. And then the right-hand side becomes x squared plus 12x plus 35. And bring the 8 over, and we get x squared plus 12x plus 27. And that can be factored as x plus 9, x plus 3, which gets me as my results negative 9 and negative 3. Now both of my results are negative here. Okay, so you got to watch this. You can't just ignore roots or discount them because they're negative. Come back up here. What's negative 9 plus 7? Well, that's negative 2. Can I take the log of negative 2? No. So negative 9 is not a root. Negative 3 plus 7 is 4. Can I take the log of 4? Yes. Negative 3 plus 5 is 2. Can I take the log of 2? Yes. So actually the negative 3 here does not lead us to a problem with the logarithmic equation, so that one works. So the answer here is negative 3.